Day 22 of doing a LeetCode problem every day until I get a job. All right, we're back again for another day, another LeetCode problem. Don't forget to like, comment, and subscribe. I'm trying to run those subscriptions up, so I need you guys to drop some likes, drop some comments, and click that subscription button right there at the top of the page. Now let's see what question we have here today. We have question 238, product of an array except self. The difficulty level is medium, so that's nothing to be scared of. We ain't scared of that. We still gonna do it. We still gonna do it even if it is medium. So what? So let's see what the question says. It says, given an integer array nums, return array answer such that answer I is equal to the product of all elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in big O of n time and without using the division operation. So, let's figure out how we're going to do that, and let's see what they want us to do. First, let's look at example 1 and see what it says. It says input nums 1, 2, 3, 4, and then the output is 24, 12, 8, and 6. Now you may be wondering, how did they get 24, 12, 8, and 6 from 1, 2, 3, and 4? Well, if you look at the input of nums 1, 2, 3, and 4, you'll see that we are trying to find a product of the array. So that lets us know product, that's a buzzword, lets us know we're going to need to do some multiplication. So let's see how we will get 12, 24, 12, 8, and 6 from 1, 2, 3, and 4. So the product of the array except self. So that means whichever index we are working with, we are not going to include that in our multiplication. So let's look at example 1. Example 1, let's say we're index 0, we start at index 0. That means we are going to multiply everything except for index 0. And if we do that, we'll get 2 times 3, which is 6. 6 times 4 is 24, so we put the 24 right here. Then we'll go down to index. Now we're on index 1. And we're multiplying everything except for index 1. And to do that, we'll do 1 times 3, which will be 3. 3 times 4 will be 12. We're going to move down again. Now we're index 2, which is 3. So we're multiplying everything except for the 3. So 1 times 2 is 2. 2 times 4 is 8. That's where the 8 comes from. Then we're on index 3, and so now we're multiplying everything except for the 4, and that's 1 times 2 is 2, 2 times 3 is 6, and that's how we get 6, and that's why the output is 24, 12, 8, and 6. The same example 2, nums -1, 1, 0, -3, 3. It's the same principles that we did in example 1. It's just this time it's a lot of zeros, so the only time the answer is not going to be 0 is when we're at index 2 and we're not including the 0 in our multiplication. Everything else, when you multiply something by 0, it's automatically going to be 0, so that's why it's 0, 0, 9, 0, 0. The 9 comes from when we were on index 2 and we couldn't use the 0 in our multiplication. So let's figure out how we are going to write this code though. How are we going to write this code though? I'm going to show you how we're going to write this code. First, we're going to declare a variable. We're going to call that result, and that is going to be equal to array. Then we're going to say, repeating 1. Then we'll say count nums.count. Then we're going to come down here and we're going to say lm is equal to 1. Then we'll come right here and we'll say rm is equal to 1. Then we come down here and we're going to start our for loop. We're going to say for I and 0 up to nums.count. We are going to start with result I times equal LM. Then we're going to come down here and we're going to say LM times equal nums I. Then we're going to, then we're going to declare a constant called Ri, and that's going to be equal to nums.count minus I, because we don't want to include the I, and minus 1, because we're going to have to, we're skipping the index as well. We're going to lose the index as well. So then we're going to come down here, and what we're going to do is we're going to say result Ri times equals Rm, and then we're going to say Rm times equals nums, Ri. And then last but not least, we are going to come right here. Oh, hold on. I made a mistake. I should never open up brackets right here. Take those brackets back. There should be no brackets. This should all be in one for loop. It should all be in a for loop. The only brackets should be when the for loop starts and for loops ends. Forgive me, that was my bad on my part. Then we're going to say return result. And let's see what it happens when we run this bad boy. Fingers crossed. Ooh, okay, it's accepted. So let's submit it and see what happens. Yeah, buddy. Rolling like a big shot. Okay, it's accepted. Runtime is 149 milliseconds, and it beats 92.88% of users with Swift. Not bad. Not too shabby. Not too shabby. Until next time, I will see you guys tomorrow.